Oh yeah, by the way, you're my first video on YouTube, so you're special.
Oh, thank you.
Yeah, you're also my most successful video on YouTube.
Uh, well, when I saw the YouTube, it was like 0 views and 1 like. I want 1 views and 1 like.
Oh,
Yeah, yeah, yeah. I
you're the only view.
then
Okay.
yeah. Am I the only view right now?
No, the video has done a lot better because like since you're my first video, everyone just clicks on your video.
Oh, okay, nice, nice.
Yeah.
Okay,
Okay.
so let me
Yeah.
share the screen right now.
Yeah. So, where did we last leave off last time?
The the drawings of circle, the big red
Okay.
circle. Yeah.
Okay. All
So
right.
is my
So,
screen displayed?
yes, I can
Okay.
see it. Okay. So just to summarize what we've done last time, we sh we saw four data types. What is data? Data is how the computer sees our information. We see 5 degrees Celsius, the computer sees 5. So we saw four ways to encode information. We saw numbers, strings, booleans, and images.
Yeah.
Um, so like with numbers, right, we could do arithmetic and algebra. We saw that we could also do arithmetic on strings and booleans. Now, I want to focus on performing algebra on other things other than numbers. So we'll explore that today. First, I want to warm your brain up since we haven't met for a week, so I just want to make sure that your brain's caught up to what's happening. Remember how we defined a function last time?
It's like X a function. Wait,
Yeah,
I forgot. Is it like this?
close without the C. Then a function needs a name. Okay. So let's do x times 2. Okay. How do we end the function? It's not that. It's a word, 3 letters long. Yes. Okay, notice how it's all highlighted. Now, how
Yeah.
do we call this function?
Um, I think I have to run it.
There's one thing a function needs in order for you to call it. Do you remember? Like in mathematics, if you wanted to apply a function, what do you need to write?
Um, should I declare something
There's something missing. If you want to refer to a function, what do we?
like
No, it's not
this?
that.
Um,
You have the right idea, but there's one thing that this function, like do you remember how we called a function last time?
yeah, we run it through the console thing.
Yeah. Yep. And we had to write something here. Do you remember what did we write?
The values.
Can you show me? Just 5? If you hit
Yeah,
enter, what will happen? Just 5, right? What do we
yeah.
do with 5?
Um, oh, okay, I see.
Okay, you're getting there. Very close. You're very
Then,
close. Let's hit enter. Okay, so let me explain what's happening. So in order to call a function, you need to refer to its function, the function's name.
yeah.
What is the name of the function right now?
Oh, there's none.
There's none, yes, so it needs a name.
Oh, I forgot.
So
Yeah.
what do we call this? Like you can give it any name, up to you. What's a good name for this function?
Uh, let's say, um,
Okay. And there needs to be a space after the fun, FUN space. And then, do you have override mode?
maybe. Wait.
Notice how whenever you
Yeah,
type, you're
yeah.
replacing. Okay, here we go.
I have it on.
Okay,
So here's the name.
so
Mul
that's very good. Okay, and let's add a colon after the closing parentheses. Okay, now let's call this function.
Then
Very
right,
good. Good. Okay. So good, your brain is now warmed up. You're caught up to what we did last time.
yeah,
So last time when we wrote functions, we wrote functions for numbers. But today I want to do something different. I want to write functions for strings. Okay.
first, okay.
Do you remember how we can add two strings?
We use the plus.
Okay. Oh, sorry,
Uh,
give me 1 second. The cat is trapped in my room.
okay, sure.
Okay, sorry, I'm back. Yeah, I didn't realize the cat was in my room and I closed my door. Okay. Okay, yeah, so yeah, could you yeah, can you take in one string and call it anything?
In the function,
Yeah, sure. Okay, you called your string. Okay, sure. Okay. All right. I would like you to say hello string.
okay.
Yeah, so in the body, yeah. Okay. Okay.
Then should I run it and test
Yeah,
this out?
let's
Okay.
test it. Yeah.
Unbound.
Hmm. Do you remember
Oh,
string? How do we write a string? There's a character we must write in order to say something is a string.
I forgot. Is it
I know you didn't
str
forget.
or
You didn't forget because I know you wrote it just now. Like look at line 8. You wrote a string, right?
this one?
Yes.
Uh, wait. Then should it be this one, right?
I don't know. Let's try it.
Oh, wait.
Do you see what's happening?
Oh, I should add the text.
Hmm.
Oh,
Okay, remember, inside the parentheses is the input for the function, right?
yeah.
What's an input?
The input. Actually, I
Like,
forgot.
no, I mean, it's okay. Look at line 3. Mult takes in x, right? And then we
Yeah,
do x times 2.
yeah,
Notice the x, there's no double quotes. It's just x.
yeah,
The letter x, it's not a number. It's not a string. The x holds a number, right?
yeah,
It is itself not a number. X holds a number. Okay?
yeah,
So same thing for string add. Inside the parentheses shouldn't be string. It's something that holds a string. So
yeah.
there shouldn't be double quotes in the parentheses. It's just a variable.
I mean, if it's how do I declare a variable for strings?
So first you write the variable first. So right now we're in the function. Don't worry about. declaring anything yet. Just write the variable first.
Okay.
So in string add, can you go to the parentheses inside string add?
String and
Yeah, let's delete the double quotes here. And let's not call it string. Can we call it like name, name?
okay.
Yeah. So there's less confusion. Oh no,
Eh,
name, like name.
okay.
Yeah. Okay. Okay, and let's delete line 7 for now. Okay, let's run this. Okay, now can you call string add and pass in a string?
Wait, forgot
Wait.
to.
Uh, okay, that's correct. Yes. Okay, don't hit enter yet. Pause for now. So you're
Okay.
gonna write Gav, right? Okay, don't hit enter. Okay, what is Gav? Gav. What is that?
It's the value that holds the name variable.
So values don't hold anything. Values in programming, when we say value, right? It's a thing that's been reduced the most. It's like the answer. It's like the number five. Five is value.
Yeah.
Okay. This GAV, would you say
Is
is it a string?
yeah, it's a string.
Are you sure what does a string need?
Oh, I see.
Yes, yes.
Okay, okay. So,
Oh, you gotta hit enter.
wait. I for I always
Yeah,
forgot.
it's okay. Yes.
Okay, okay. I see.
Nice.
I'm starting uh to remember.
Yeah. Okay.
Okay.
So one thing I want to mention, notice how on line 7, the parameter name. So we call the input a parameter, the parameter name. Notice how there's no double quotes. It's just a
Yeah.
variable. But the variable will hold the value. How does it hold the value? When you call the function string add gav,
Yes.
it will take on the value gav. Okay?
Okay.
You understand what's happening?
Yeah.
Okay, good. So this is algebra, but with strings, right? Same
Right.
thing, right? Same thing with numbers.
Uh,
Next, I
yeah.
wanna. Mhm.
And it's a little different by the syntax wise.
Exactly. Yes, you're
Yeah.
writing the same thing, but you're just working with strings. Yeah.
Yeah.
Okay. Well, let me think about this. I need to introduce a new idea. Okay. First, I want you to create a new function called
What
distance to
should
origin.
why distance
To origin.
to
Okay. I'm not sure how much mathematics you know, but this function takes in two numbers, x and y.
x and y?
Yeah. So it in the parentheses write x and y. Okay. Here's what I want you to do. I want you to compute the distance to origin given x and y. Are you familiar with this? I don't know if you learned this in mathematics.
No, actually I don't know the mathematics of the distance of origin.
Okay. Okay, I'll tell you the answer, but I let me know if it doesn't make sense. It's the square
Okay.
root of x squared plus y squared
Square root of x square
and y squared.
and y square.
Have you heard of this before?
Yeah, I heard it from my friends saying that x square and y square. But I
Okay.
don't know how it process how the process.
Okay. So let's start with this. Can we square x? How do we square x? Yes. Keep going. That's times 2. That's
Uh,
oh, that's not square, right? We need
yeah.
x to the power of 2, not x times 2.
So I use the x again.
Yes, yes, yes.
Okay.
Very good. Okay, and then we need to add to y times y. And then we need to add both.
Yeah, it will be the value of x square and y square,
But
right?
we need to add them, right? How do we add them?
I will run it here at the console.
No. Like we have x squared and y squared, right? But these are two numbers. How do we combine two numbers by adding them?
Oh, plus
Plus.
x plus y.
Yes, let's do it.
Okay.
Uh, Actually, we need to add the x times, so it's x times x plus y times y. You know what I'm saying?
Here,
Between x times x and y times y, there should be a plus.
like in the not the new line.
Not new line. All these should actually be in one line. So line 12 and line 13 should be in one line.
Oh,
And then between them should be a plus.
between them. Okay.
Not there. So the plus should be between, yeah.
Yeah.
But you don't need to do x plus y, just plus. Yes. Okay, perfect. This is
Okay.
perfect. Okay, so this is close, but you need to square root everything, but it's okay. We don't do that first. I'll save that for later. Let's run this and see what happens. Do you remember seeing this?
Oh, I have to group it.
Yes. It doesn't know. Does it add first or multiply first? So you have to tell it.
Okay. Okay.
Wait, pause. Notice how this parentheses holds two operations. It has the plus and times in the parentheses.
Yeah.
Huh. But we only need to make sure there's only one operation in the parentheses.
Also, we should have one operations per parenthesis.
Yes.
Okay.
So,
So is it like this?
yes,
Y-
yes. Perfect.
Oh, okay, okay.
Yeah.
So no, it should be in the rule, right? One.
This is close. The y times y is correct, but the plus, the parentheses before the plus doesn't need to be there.
Okay.
And then, yeah. So delete that parentheses. Okay. Okay, very good.
Okay. So
Distance to, oh, typo, line 11, or regreen.
oh
Oh, you have to run again to refresh.
yeah, 370.
Mm, mhm. Okay, so now this is actually distance squared to origin. We need to square root this whole number.
Okay.
How do we square root a number in this language?
The 370
Yeah.
square root. If we're going to square root this into a bigger number or into a smaller number.
So smaller. Yeah.
Um,
How do we square root in this
Division,
language? Okay, so
division, divide.
I'll tell you right now, you need a special keyword. You need a function to do this, and this function is provided by the language. But what is this function? Okay, so
Sl- Okay, slash. No.
it's not slash. It's a word. So in programming, right, you're going to need certain functionality. For example, square root. The language probably has it, but you don't know what's the name. You need to figure it out. How do you figure it out? You need to use Google.
Okay,
So before you Google anything, I want to warn you. When you Google something, right, either use incognito or make sure that your search bar is like clean. You don't want like for example, your full name to be in your search bar.
okay.
Okay. So however you do it, can you Google so this language name is pirate. So can you Google pirate square root? Yeah. And then scroll down until you see, oh my gosh. Wait, can you
Hmm.
scroll down a little bit? I feel like these are all the
Python.
wrong. No, we're not looking for Python, we're looking for pirate, but sorry, can you scroll down a bit more? Oh yeah, wait. It's the pirate. Do you see it? Scroll it down a bit. This one. No, the one below pirate. This one, yeah.
This one.
Yeah. Oh
Doubles.
my Lord. Okay, they'll yeah, just do Control S square root. Hopefully it will give you the answer. Okay, so usually documentations are a bit better. Usually when you Google it, it just tells you immediately. Oh, there we go. There it is. Okay, so let's pause here for a second. I want to look at this. So this here is like a dictionary. When you're learning a language for the first time, chances are you need a dictionary. When you
Yeah,
see a word you don't understand, you can look up the dictionary. But here's the thing. When you're learning a language, right, you don't read the dictionary from A to Z, right? You
yeah,
read the dictionary when you need it. Same thing here. This is like a dictionary, but in programming we call this documentation. These are like explanations for the words of the language, right?
yeah.
So last time we saw num min. I don't know if you remember. We used num min last time, like for the minimum.
Yes.
Here there's num square root, or here they
Okay,
call it SQRT.
okay.
So there are two parts here. Notice how and I'm going to draw on your screen. Give me 1 second. I'm going to pull out my pen. So there are two parts. Can you see my drawing?
Yeah,
So here we call this the signature. This num square root is a function. You can see it has a name, input, and output. Notice how you see the data type. It takes in number and produces a number, right? These are data types. Okay.
yeah,
So it tells you I expect to take in a number and you can expect to take back a number, right?
yeah.
We call this the signature. I'm drawing my mouse right now, so it's gonna look ugly.
No, it's okay.
Signature.
Okay,
So a signature is like data, but for the function. This is how the computer understands the function.
I
The computer
see.
sees, is the name is num square root. It will take in a number and it will give back a number. This is how the computer understands the function. The thing below
Okay,
here, this is a human readable description. This is for the human. Okay? So the one on top is for the computer, the one below is for the human. Okay?
okay, yeah,
So remember last time we talked about information and data? Information is for humans, data is for computer.
yeah,
Okay, same thing here. The description is information for the human. The top is the signature, which is data, and it's for the computer. Okay?
okay.
Okay, now that you have seen this, let's apply this to our code. Let's use this. We need to square root everything. Oh, but keep the documentation open. You might need it later.
Okay. Oh, wait.
Interesting. Okay. But now we need to do num square root, but on the output of distance to origin.
Is it 370? Should I put 370 here?
Yeah. So okay, what you're doing right now is you're checking square root of 370, right?
Yeah.
But what I want to do is the square root of x squared plus y squared.
Oh, okay.
Yes. So yeah. No, I'm glad you did this. I want to explain this in a moment.
Okay.
Yeah, yeah. So sorry, continue.
Should I continue
Yeah, yeah, continue. Where would you put the square root for distance to origin?
from distance to origin?
Yeah. What are we square rooting here?
The value of
Yes.
the sum of x square and y square.
Yes.
So, how should I call this one? Should I declare it first here?
So there are two ways. There's one way. Yeah, you can declare it here first. How do we
So,
declare it here?
um, s-
Sum. Okay, very good. So very good. Making use of variables. Okay, yeah. Okay, good. Let's run it. Oh no, no, no. Can you bring that back? Yeah,
okay.
yeah. I'm gonna use that in a moment.
Okay,
Okay, let's
okay.
run it.
Test failed one.
Okay. So let me explain what's happening. So this check block, line 16, the check is running tests.
Yeah.
What it does is when you write something is something, like num square root 370 is 2, it's checking, is num square root 370 2? Okay?
Mm, okay.
But num square root of 370 is not 2. That's why I'm saying no, it's not.
Okay.
Can you replace line 17 with a call to distance to origin?
All distance to origin. Okay.
Yeah.
Should I put it here?
Can you replace the num square root? I I don't I want to replace the num square root entirely.
Num square root here?
Let's replace that with distance to origin.
Okay.
And let's delete num square root. No, no, not that one. No, no, keep that one. The one on line 17. Actually, I can draw, right? So I should start drawing. Yeah,
Yeah.
perfect. Let's delete the parentheses as well.
Okay.
Yeah, and now let's call distance to origin. Let's call distance to origin um with I'll give you two numbers, 3 and 4.
Um,
So distance to origin. So here, can you see my drawing?
okay. Yeah.
So yeah, immediately after distance to origin, opening parentheses 3, 4. And then the output is 5. Do you know Pythagoras theorem?
5.
3
Yeah.
squared plus 4 squared is 5 squared. This classic example. Okay, can you run it now? Okay,
Okay,
this is a
okay.
bit of math. Yeah, maybe I shouldn't use so much math for you. Okay, let's
Yeah,
run
it's
it.
okay. Yeah, it's new knowledge. Why?
Okay, great. So our test
I
pass.
passed. Yeah,
Okay, notice how you don't have to check manually. You can just hit run and you'll know if it's correct. You see that?
yeah.
So this is the benefit of testing. You can write it once and you just hit one button and it will always tell you is it right or wrong. Okay?
Okay.
Okay,
So
so I wanna, yeah.
it's like a test block.
Yes,
Like
exactly. That's what it
you,
is.
yeah. Okay.
You know, notice how they call it checking? They call it
Yeah,
check because it's what you're doing. Whenever you're comparing two values and say, is it correct? You're doing a check.
yeah,
So distance to origin 3, 4. Is it 5? Yes. Okay, good.
yeah.
Check passed. Yeah.
Okay.
So I want to summarize what we have done. So we have done algebra with strings and we have performed a more advanced algebra with numbers. Yeah, and you figured out that you're able to use a variable in line 12 to break down the computation, right?
Yeah. Right.
Great. And we also introduced testing. So from now on, I want you to do some testing to simplify your life. All right.
What is life?
Sorry, drinking some water.
Yeah, sure.
Okay. Now I want to introduce an algebra for booleans. Do you remember what are booleans?
True or false?
Yes, true or false. I think I didn't mention this last time, but if you notice, right, numbers, there are many numbers. 1, 2, 3, 4, 5. For strings, there are many strings. Hello string, Gav, Marvin. You can write many strings. For
Yeah,
booleans, there's only true or false, right?
yeah.
Okay. Uh, okay. So this, hmm, let me, this one I think is quite hard, but I think it will be good exercise for you, so I'm gonna make you do it. In so we're gonna do some logic now. So logic is a bit of mathematics, but it's not mathematics with numbers. It's mathematics with true and false. There's a thing called implication. For example, if it rains, I bring an umbrella. In mathematics, we call this an implication. So I want you to create a function called implies. Uh, okay, can you do that first? Create a function called implies.
Is the spelling correct?
Yes, perfect. And opening
Yeah.
parentheses, and it's going to take in A and B. So just A comma B.
A, B.
Okay, now leave the body blank for now and just write E and D. Okay, so I'm going to tell you what the answers should be. So can you do a check, create a check block below implies? So check colon. Okay, now inside here, I want you to write implies, opening parentheses. False, false is true.
Okay.
Okay, next. I want you to write a new line in after line 25. Implies again. False, true is false. Sorry, false, true is true. New line again. Implies true, false is false. And then finally, implies again. True, true is true. Did I explain truth tables last time?
Yeah.
Okay, so this is a truth table, but coded into our language so that we can check.
Okay.
Okay, here's an exercise for you. I want you to fill in line 21, the body of implies, so that all the tests pass.
Ha.
Okay, good luck.
No.
Oh wait,
Okay.
I need to give you one more thing actually. I just realized. Okay, wait. There's one more thing I need to give you. Give me 1 second. Uh, yeah. This is not easy, but I mean, it's not hard, but it's not easy. You know. So yeah. Okay, in Zoom chat, I'm gonna send you a link. It's the documentation for Booleans. It's like the dictionary but for Booleans. I want you to This one is very easy. There are only three words in this dictionary, so you can just read it. And these are your Boolean operations that you can use to achieve your task. So there's not, and or. You see that? Only three.
And yeah.
Okay, good luck. Let me know if you need any help. I'll be watching you.
Uh, so I should like it should pass all the tests, right?
Yes.
Okay.
So I just realized something. I need to give you a new Zoom link. This one's gonna expire.
Oh, okay. Yeah, sure.
All right, so check your Gmail, okay? I'll see you in a
Okay.
minute. Yes.
Okay. So,
So the operator that you're looking for
or
is OR. It's
Yeah.
not that symbol. It's or
Oh, okay.
lowercase.
Okay, okay. I should use this one, right?
Yeah, but
And
lowercase.
okay. Okay,
Lowercase. Yeah,
okay.
yeah, yeah,
Okay. Thank you, thank you.
yeah. That's not the one.
Oh,
It's
okay.
uh, it's not from booleans. Keep scrolling. Oh, there. Yeah, not from booleans. Nice. Okay, how did you
Oh,
know?
wow. Oh, what the?
Wait, how did you know?
Ah, ah, I don't know, but um uh why though? Wait. I just thought that if I use not for the A, uh then it will like it's like a positive negative on a battery. So I just thought
Okay,
that it may pass all the tests when uh there's one value that alternate he I mean there's one value that has a counterpart.
sure.
Yeah. So that's why I'm at the first uh testing that I use not, because I should use not, and I'm contemplating on this part whether I use a and or.
Okay,
So yeah, that's why I thought of using not.
interesting. Okay, nice. Well, congratulations. This was not easy. Congrats. Um,
Yeah, really.
okay, so see- the key, there are two key ideas here. The first is that notice how the only case is false is true false. Line
Yeah.
27. So that's the only case is wrong. So it implies, right? Here's what implies. So okay, you don't need to know this. I'm just telling you for your benefit. When we implies, right, it's we're making an implication. So let's say if it rains, I'm gonna carry an umbrella. Okay? If it rains, I carry an umbrella. So I am not carrying an umbrella. Did I lie?
Excuse me, can you repeat the
So
question again?
let's say if it rains, I carry an umbrella.
Yeah.
But I'm not carrying an umbrella right now. Did I lie?
No,
Why not?
because you bring an umbrella but you did not carry it.
No, no, no. Okay. Uh,
Oh,
no, no. Let's say bring and carry is the same thing. Bring an umbrella,
yeah.
carry an umbrella. Let's say it's the same thing.
Okay.
So I say, if it rains, I bring an umbrella,
Yeah.
and I'm not bringing an umbrella. Did I lie?
Yes.
Why am I lying?
Because you just said you bring an umbrella and now you did not.
But I
So
said
it's
if it rains. I said if it rains, I will bring an umbrella.
yeah.
But let's say maybe it's not raining.
Oh, okay. Yeah, I see.
So I may not be lying, right?
Yeah.
So if it's not raining, it doesn't matter what I do. I will not be lying,
Yeah. It's either you bring an umbrella or what. It's not raining.
right? So
Yeah.
lines 25 and 26, whenever the first one is false, the result is true.
Yeah.
Because if it's not raining, it doesn't matter what I do, I will not be lying. Okay?
Yeah.
But let's say I say if it rains, I will bring an umbrella. It's right now it's raining cats and dogs, but I did not bring an umbrella. Did I lie?
You might.
I am lying,
Yeah.
right? If it's raining and I say, okay, if it rains, I will bring an umbrella. And if it's raining and you don't see me bringing an umbrella, it means I lied, right?
Yeah.
So that's why line 27, true false is false. It's raining and I didn't bring an umbrella. So it's false.
Yeah.
I lied. So this is the meaning of implication.
Okay, I see.
This is like this is an idea in logic. It's official. But you don't really need to know this. I'm just letting you know. Um,
Okay.
so the trick to solving this is realizing that the only case it's false is true false. So you are correct with not A. The reason why not A is important is because if A is false, not A will become true. Okay?
Yeah.
That true is important. Then the second one, or why we do or, if the first term is true, we want it to be true because of lines 25 and 26. Okay?
Yeah.
And then the second case for or, if not A is true and B is false, sorry, I mixed it up. If not A is false and B is false, we want it to be false. If not A
Yeah.
is false and B is true,
True.
we want
Yeah.
it to be true, so we have to use the or operator. Okay?
Yes.
Okay, anyway, this is not important. This you can forget this. Like after this session, you can erase this from your memory. This is not important. It's good to know, but it's not important. Uh,
Well, I I might be against it because I feel like this will be at the next meeting.
we'll see.
Yeah.
We'll see, maybe. Um, I think you only need to know this if you're like a mathematician.
Okay.
Yeah. Anyway, the reason why I gave you this exercise is because I want you to get practice with algebra, but with booleans.
Okay. Yeah.
Notice how we have a function, takes in booleans, and
Yes.
notice how we use two boolean operators, not and or. Yeah.
Yeah.
Notice how we also made a truth table using checks, line 25 to 28.
Yeah.
Yeah.
I see.
So this is why I gave you this problem, is to get you exercise on all these parts. Okay. I think I don't know. We may have time for one more thing.
Uh, Is it like 7 minutes? Yeah,
No,
we
no,
still have
I'm not.
7 minutes.
I'm not gonna give you a new problem. I'm gonna show you something different now.
Yeah.
Remember,
Okay.
let's. I want you to draw. Do you remember how to draw a circle?
Circle
Yeah.
here at the program.
Yeah.
I
Do you
forgot.
remember?
Y-
Okay. So I'm gonna show you the dictionary for images. I'm gonna paste it. Actually, wait, no. You have the dictionary open. Can you open the dictionary and search up circle? So yeah, if you forget, just search it up here and then you can recall it. There we go. Oh wait, actually, can you bring it back? Can you save this file just in case? If you want to
Oh,
refer to it in
okay.
the future. I know this is recorded, but I think it's good to keep it so you can.
Okay. How should I save it? Should I connect to my Google Drive?
Okay, maybe do this after. I'm scared that you might reveal
Okay.
some
Okay.
information online. Okay, it's okay. You can delete it for now. It's all recorded, but let's if you want, you can connect to Google Drive in the future.
Yeah.
All right, so yeah, we got our circle. Okay, I want you to learn some arithmetic with images. So we learn how to add images together. Um, can you go to the dictionary again? Can you can you scroll down but on the left hand side? Yeah, so this is like the index. Scroll down, keep scrolling down. So you see there's data types. You
Yeah.
see basic images. Okay, now let's keep scrolling until we see combining images. Keep scrolling. Polygons. Overlaying images. So let's look at overlay. What's overlay? Ah,
Yeah.
can you practice using overlay here?
Okay. So
Yeah, perfect. Nice.
yeah.
Okay,
So
so yeah.
is this the like uh addition? Like it adds over the top?
Yes.
Oh, okay.
Yeah, so the same way we can add two numbers, we can add two strings, we can add booleans, we can also
Yeah.
add images.
Oh, I see.
And you can use the dictionary to help you find what are these add operations. So here's overlay, there's a few others. Um, okay, so I have a theory question for you. Can you
Sure.
go back to the code? Okay, so right now this overlay, what it's doing is it's taking the middle of one image and putting it on the other middle of the images. You see that?
Yeah.
It's like skewered in the middle. Then what if I wanted to have a function that puts one image overlaid another, but it's not necessarily in the middle. It's like we can adjust where it's overlaid. You get what I'm saying?
So it's not
Like,
in the middle.
or not necessarily, we can adjust it. We can move it to the right, we can move it to the left, we can move it up or down,
Yeah.
right? So that's information, right? That's information which is what's the X and Y offset? Like, how much to the right do I want to move it? How much to above do I want to move it? Right?
Yeah.
So this is information. And part of remember, we turn information to data. So how could I encode that information?
Think you should declare it as a variable here at the value numbers.
These
How you sh
numbers,
or
remember
should you
this,
yeah.
sorry, go on.
So or should we create a function for this?
Okay, so we can't actually create a function for this. This function needs to be created by the library. We need to use what
Oh,
they gave us. Oh, when I say library, it's code that they gave us. Um, but for now, I'm just asking you, if the library were to have this function, right?
yeah.
How is the information, the idea that I'm going to call it the offset, right? How offset one shape is from the other. How would this be encoded?
Um, I don't know. I don't really know how.
Okay. Um, for example, let's say I want this rectangle to be to the right a little by 10 pixels.
Yeah.
So the information is I want the rectangle to be the right by 10 pixels. What's the data here?
Is it the X?
There's no letters involved. Remember, okay. Like if I want to move the rectangle 10 pixels to the right, 10 pixels. So the information here is 10 pixels to the right. How do I turn that into data?
Um,
No, this is a theory question. It has nothing to do with code.
okay.
Yeah, there's no code involved.
I mean, if you want, then
Okay, I see that I fried your brain.
Yeah.
It's okay. We'll pick this up next time. But think about it, when
Okay.
your brain's less fried, rewatch this video and listen to the question again.
Yeah, okay, sure.
Okay, let's pause for here. Let's let your brain recover. Okay.
Okay.
All right, I gotta end it here. I hope you learned something today, and I hope to see
Yeah,
you again.
thank you. Okay,
All
I
right.
hope to see you again. Thank you.
All right, no problem. Bye bye, y'all.